So a quick recap of async features. Okay, so my VS Code. So I sent across this repository. This was the course this was the module material. How many of us actually looked at it? If you did, give me a thumbs up. How many of us looked at the okay. So I'm just going to assume we all went through it, right? Okay, this is just the summary of what I was explaining, but I'm not going to go in depth. I'm just going to explain the examples and what's going on. Okay, first of all, we have error handling in features, right? The most important thing to note when you're handling errors in future is to always call await. Okay, when you want to use a try catch block, always make sure you're calling an await. I can't overstress how much this kind of things crops up. We forget to call await and yes, we want to catch an error and you don't catch it. That is because that feature is not run inside the try and catch scope. Okay, so that is what we are doing here, right? We have this main function. Okay, we have this main function, and you can see I'm calling in future one. My future is future one. Let's go to the definition of future one. So let me remove all these comments so you can be cleaner. So you can see what I'm doing, right? So the definition of future one throws an error after 3 seconds delay, right? And because we are awaiting it inside wrap future, what we call it, any error that is thrown is going to be caught and logged using this log function. Okay, but if you forget to await it, the error is not going to be caught inside this try catch block. And I also mentioned the use of finally, right? Finally is a block that runs whether your feature resolves with a value or your feature resolves with an error, provided that you do not rethrow. Okay, and now this is very, very important. If you rethrow the error inside your catch block, finally block is not going to run. Now, this is another common bug that might frustrate you if you miss it. Okay, so and that is for error handling in futures. So I also talked about
Please, sorry, sir. Please
computers.
come again. You said if we state the retro inside in the catch block that our finally will not run. I didn't get that. Sorry.
Okay. What I explained is here we have a wrap feature that calls another feature. It calls feature one and feature one throws an error, right? And it is caught here and it is logged. Now, finally block, now follow me, right? A finally block is run. And whether your feature resolves the value or it throws an error, right? It's run. Okay, this is where you can do things like recovery or any other thing you want to do. Okay, but I explained that this finally block will only run if this rethrow is absent. Like now, here we have a finally block, right? If I run this code, all of you have access to the repository. You can always pull it and run it to see what I'm saying. Okay, if I run this code, this finally block, this log finally wrap feature one is not going to run because I'm rethrowing the error I caught from this feature one. Remember that this feature one throws an error, right? Throws an error here. So this finally block is not going to run. What happens is this error is going to be rethrown to the entry point. Where is the entry point? The entry point is the main function. Okay, so think about it this way: feature one throws an error. It is caught by the caller, which is wrap feature one. The caller does something he wants to do with the error and decides that he wants to rethrow it. Now, rethrowing it means wrap feature one is not the one that is going to be having an error because it's simply returning an error it caught. So that error is not going to propagate up to this main function, and this main function is going to exit with an error. Okay, so if you run this code, you see all this in action. Okay, so Does that answer your question?
Okay, yes, sir.
Okay, thank you very much. So I also mentioned completers. Okay, and I think someone was asking me, why do we need to use completers? Why do you need to have completers? Well, completers are really, really important. Most times they're important because there are some things that normal writing functions with async cannot do for you. Okay. Okay, let me give you an example. An example. If you've used any routing manager, either get or go router. Okay, I've used both and I use both, right? There's sometimes you want to push a route. Okay, you push a route, and when that route is popped from the stack, you want it to return a value to you. Now, under the hood, the mechanism uses a completer to do that. So we'll be seeing an example of that when we start building our satisfied application. Okay, so a quick recap of how completer works, right? So basically, a completer is what allows you to programmatically complete a feature, either resolve a feature or kind of throw an error. So I feel like one thing I love about that is the naming of things. The names are so intuitive that you don't have to worry about, you don't have to think about it. Once you see the name, you know what it does. Okay, so we have this completer. So what this thing does is, anyway, you have a completer dot complete. Okay, what it will do is it will resolve the future associated with that completer. The future associated with the completer is this completer dot future. Okay, anybody that is waiting on it, okay, anybody that is waiting on this completer dot future, anytime you run completed or complete, this feature will resolve. Now look at this example now, okay? You can see that okay, this example still uses feature one and wrap feature one, okay? You can see feature one returns the future, okay? But you can see it doesn't have the normal async annotations that I normally have with feature functions. So pay attention to this, right? But it returns the future. Where is that feature coming from? It's coming from this completer. The completer kind of wraps a feature. So you can see when I call completed of feature, it returns it to this thing. And the return type is a type of string, right? And that's why when I complete it, I have to complete it with the type of string. You can see where I call completed or complete, I'm giving it a string value. Now, this string value I'm giving it. Okay, Ginika, you're raising your hand. Let me complete this thought before you ask a question, okay? This string value I'm giving it is what is going to come out here in results. Okay, so if you run this code, okay, you're going to have result feature one result equal to feature one result in your terminal. Okay, like I said, you can always pull the repository and run the code. Okay. Okay. Kinika, what's the question?
Okay, thank you very much, please. Is this complete stuff? So
Okay.
there are few things like when I was studying about it, it's like every time is about to be used. It's like is that final completer something? Is it like a declaration, like sorry, dependency injection, something like that before so that you can assess it? And the second question is in that completer dot complete, can we pass a widget also apart from maybe string, int, all those things? Can you pass a widget like maybe you are passing next screen because you talk of navigation? When you want to complete the future, can you pass a screen after the future is complete? Is it possible? So that's like two
Okay.
questions I'm asking, please.
Okay. I'm not sure I got your first question completely. Could you like kind of paraphrase it, but in
Okay,
better way?
okay. Like this final completer is equals to like you're accessing the completer object. If that's what I'm seeing there, is that what that's if you want to access this completer method or
Okay,
what
good.
it is?
Before you go to the next question, let me answer this one now. So you're
Okay.
talking about this line of code, right? This one I'm highlighting.
Yes, please.
Okay, this is just like how you create any other object. Okay, completer is an object. You know how to construct an object now. This is a
Yes,
constructor, and
yes.
completer is a generic type. You know what generic types are? Type generics.
Yes, you can take any type.
Exactly. A type generic is a kind of a class that kind of wraps other classes in the sense that you can give it any other type that it can hold or it can make reference to. So here now inside this type parameter, mind you, when you're constructing a generic type, you have to give it a type parameter most times. So the type parameter I'm giving it is string, but I can give it something like let's say I had a class named login screen or named anything. I can always pass the name of that class inside this type parameter. And what that thing means is any type I give it when I'm constructing it is a type I'm going to complete it with. So you know that I'm passing it a string, and that's why here I'm calling complete with a string. If I pass something like an integer, let me show you now, the IDE is going to scream at me. So can you see this, Kinika?
Yes, I can.
Because I declared it the type of string and I'm trying to complete it with an integer 78, it doesn't work
Yeah.
that way. Okay, but if I do this, change the type to an integer, you can see the IDE stops screaming at me.
Yes,
Can you see that?
yes. Yes, please.
Okay.
Okay,
So
so
your second
that,
question.
yes. I'm asking, can we pass, like you called login screen, can we pass okay, for example, you say we can pass login. So what does the future return? Is it always a string, or what will the future return? And you also made mention of navigation. When we say completed or complete, can we navigate? How do we use it to navigate to another screen? Talk about routing. So firstly, if you return a widget or a login screen, what will the future be like? What is it going to complete? And secondly, how do you use it to navigate? Okay, you said later we'll talk about that one, right? Okay, no problem.
You know what? Okay, I'll get to your question after the class, right? I've never entered what we have to do today, okay? But this particular question, but from what I'm hearing you say, like the use case you're talking about is not how I asked you to use it. You're talking about the assignment, right? I'll explain that one in a
No,
bit,
no,
probably
it's
after
not.
the
It
class.
wasn't sharp from the assignment. It was from this string that I'm seeing. I want to know,
Okay,
apart
okay.
from the primitive types, all those things, can we pass in
Oh,
classes? And what if you pass in classes,
uh,
what does it complete with? It's just what I wanted to understand.
yes, you can pass its classes. So let me just show you this example. Okay. You can see I declared a simple class here named course. Okay. So when I'm declaring this completer, I give the type parameter of course. Now, what this thing means is anyway I'm completing it, I have to complete it with an object of course. So because I'm completing with the string instead of a course, the IDE throws an error for me. But if you can see, when I do this, you can see everything is now resolved. Can you see this?
Okay, yes, yes. So why is the
Okay.
completer dot future returning an error even when you made it an integer that time?
Okay. Well, completed a feature is returning an error. Remember, because this feature that is wrapped inside, okay? Look at this feature one. Look at this feature one. What is the return type of feature one?
A string.
String, good. But now we are returning a completed of feature, and this completed of feature
Okay,
is a
okay,
feature of
okay.
course. Do you understand?
Yes, yes, I do. Okay,
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 that's why
okay.
it throws an
Thank you
error.
very much.
Okay, so let's
Yes.
move on. Thank you very much. Okay, so that is about computers, and every other thing you can always the error handling of computers is not very different from the one of normal feature functions like defined with an async annotation. Okay, you can see here if I complete this feature with this feature result, the result is going to come out here. Okay, but if I throw an error, say I uncomment dot completed or complete, and I comment out completed or complete, and I uncomment completed or complete error. Now, what this feature does, instead of resolving with the value, it throws an error, which is going to be caught by this catch block. So everything is as it used to be. Okay, so I understand that it takes some time getting used to, but the important thing is when you understand the use case and where you can use it, you appreciate the value of it. Okay, so what we have for today is actually streams and stream controller. I don't know, is any one of you familiar with streams and stream controller? If you are, raise up your hand. Okay, thank you, Ginika. Streams and stream controllers. Okay.
Yes, but I've not really worked with it before, but I've studied about it anyway.
Okay. So, okay, I'm going to explain streams with this analogy. Well, not really an analogy, but work with me here, okay? So you know how a future must complete with a result. It gives you one thing, okay? Asynchronously. A feature is going to complete the result asynchronously. It gives you one thing, okay? But think about the situation where you need to have more than one result coming in, but asynchronously, okay? You could do something, well, if, I'm not saying there's no way to do that. Of course, someone that likes to write code from scratch, doesn't want to use already existing tools, might want to, find ways to do that, maybe using for loops and features and everything. But that is why streams exist. Okay, the very, very smart people that brought out that programming language has implemented streams for us as a pipe that kind of vomits out values asynchronously whenever they are available. And asynchronously means it doesn't wait block. And that is very, very important when you're building UI applications. Remember that when you're building a UI application, your screen has to update. There's something called frame rendering. Okay. Your frames are being rendered most times when you have 60 FPS, that means 60 frames per second is being redrawn on the screen consistently. So anything that you do that blocks the main thread, is going to most likely cause your application to skip frames or have this jank. It's called jank actually, have this jank effect. So that is why asynchronous handling of data is very, very important. And stream helps you handle multiple asynchronous data coming in at the time. For instance, say you're building a chat application, right? Where messages, you don't know when messages will come in, but messages are sure to come in. You understand? And you don't have the messages, let's say you're connected to a messaging service like RabbitMQ, Firebase messaging or something. And also, if you look at these SDKs like Firebase messaging, they work with streams. They use streams, okay? And this is what they are for. So messages are going to come in, but they're going to come in asynchronously, and you can't control when they come in. What you have to do is react to them when they come in. This is where streams come in handy. Okay, so moving over to how to create streams. And please, if you have any questions, don't hesitate to raise your hand. Okay. How to create streams. The number one syntax of creating streams is to create a function or a method and annotate it with async. But now, instead of an async, you have async star. This is what makes it different from a normal asynchronous function. This star, you can see now if I uncomment this star, ID screams at me. If you can see my screen, it screams at me. And when I hover over this area, you can see functions marked async can't have a return type, which is super type of future, blah, blah, blah. Basically, what it's trying to tell us is that this is an async function, so its return type must be future. So, but if I add a star, then its return type must be a string. Okay. So let's go back to what this stream is actually doing. So this string it has a return type of string. That means it's going to be vomiting values of strings as time intervals, depending on when the values are available. So immediately I listen to this string, it vomits a value message 1, okay? And it's going to wait for 1 second. And just like in future functions, you can also use await in functions like this, okay? It's going to wait for 1 second, and then it's going to vomit another value, message 2. okay? And it's gonna wait for 1 second and then vomit the final value message tree. Now, this is a very primitive implementation, right? Let's run this code for a minute. I had prepared this example for us before time, so we wouldn't waste much time. Okay. So let me quickly comment out this main function. Now, I'm going to call string get messages. Okay. Now, a very important thing to note, right, is for you to get the values from a string, you have to listen to it. Think of it much like for you to fetch water when you go to a stream, you have to actually put your bucket and put in the effort, right? So this just doing this final string call to get messages, it's just gonna give you the stream value. But this code inside here is not gonna run actually. So you have to listen to it. So how do you listen to it? You listen to it by calling string.listen. Then you give it a closure function. Now this closure function takes one parameter, and that parameter is the value that comes out from the string. And when that value comes out, we want to, of course, the value is a string already. So there's no need converting into a string. Okay. So what will happen here now is that this string is going to vomit message 1, message 2, message 3 at an interval of 1 second and then complete exit. Okay, so let's run this code. Wow. Okay, so can we see what's going on? So you can see it printed message 1, message 2, message 3 at intervals of 1 second, and it exited. It exited because the stream has no more data. It has completed. Okay, so this is a very primitive example, right? For instance, you might want to do something more interesting with a for loop. Okay, say, this is going to take a lot of time. 100. So I want to do something more interesting. Same with the for loop, and now I'm changing the return type of this string to an integer. Remember the previous time we returned strings. Now this string is going to be emitting integers instead of a string. So when we run this code as expected, this is what it does. Okay, so okay, you can see I put 5 seconds instead of 1 second. I'm sorry, we can't wait that long. Okay, so but I'm sure we get the idea. Okay, so just like features, streams can also throw errors. It can also spit out errors to you. And most times what happens is when a stream throws an error, okay, it kind of exits. It doesn't complete the value. For instance, if I add the logic that says if I equal to 3, throw equal to 3. Okay. So if I do this now, you can see this string is not going to complete up to 5. It's just going to stop at when I is equal to 3. We are not handling the error. Okay. Oh, wonderful. So you can see what happens. We just got to 0, what it just gave us 0, 1, 2, and when I became 3, it kind of exited. And see an unhandled exception. But we can react to these exception conditions by attaching a callback called well, let's do it inside rather a closure. So let me okay, Ngozi, Ngozi, go ahead with your question, please. Ngozi, go ahead with your question. Hello? Ngozi, can you hear me? Okay, I think she's having a bit of technical challenge right there. Ngozi, let me know when you are back, if you can hear me, so you can ask a question. Okay, please confirm you can still hear me. Anyone? Ginika, can you hear me?
Yes, sir,
David,
I
can you
can
hear
hear
me?
you.
Yes. Okay, thank you very much. Okay, I think Ngozi is having a bit of challenge right there. Okay.
Okay, sorry,
So,
sir. I wasn't hearing you.
all right, go ahead with your question.
My question is about the last class. I was trying to search for the recorded class on YouTube, and it's still not been uploaded.
Sir, I don't.
I'm
I can't
saying
hear
that
you.
the last class. I'm saying the last class has not yet been uploaded. Sir, did you hear me?
The last class, right? Okay, yeah. I sent
Yes.
something in the group. We are working on it.
I'm
Okay,
just
we're working
wondering
on
if
it.
it would be the same with this, because I've been looking out every day for the uploaded video to try to do a recap of last class, but I've not been able to do that.
Okay, it will most likely be
Mm.
combined with this one because we had some technical challenges, the background noise and interference and everything. So, but do you understand everything we've taught so far?
Yeah, I wasn't listening for the last five. I didn't know that my audio was
Okay.
mute, so I wasn't hearing anything, but I was seeing the screen.
Okay, I did the recap before we started today, so just be on the lookout for that. Okay. Okay, thank you. So back to streams. Okay. So I was explaining that just like a feature, a stream can throw an error at you too when something goes wrong. And I simulated that condition here. You can see that the stream didn't get to, we are using a for loop. The stream didn't get to I equal to 3, and it threw an error at us. And because the error is not handled anyway, our program kind of exited. Okay. So, but we can handle errors gracefully in stream, just like in features. Okay. By adding a callback. In JavaScript, it's called callbacks, but I like to call them closures in that. Okay. When I open up the documentation for this dot listing method, so I don't know if you can see, it's up here. You can see it takes in on data closure, on error closure, on done closure, and cancel on error. So basically what this thing does is on data is a closure that will be run every time the stream gives you a value. And we already have that here. We have this first closure that we just print the data to the console. So when the stream gives us I is equal to 0, I equal to 1, we just print it at the console. But in an application, you might want to do something with this. Maybe it's a chat application and the stream is giving you a stream of messages. Okay, you might want to maybe store that in your database or update your database or maybe funnel it to somewhere else. Okay, depending on your use case. So to handle errors in streams, we add an error callback. Let me just call them callback. Okay, an error callback. And now this is how to do that. Error callback. So I just want to print the error and print the type of the error. Okay. So when we run this code, we are going to get values up to 0, 1, 2, but then it's going to give us an error at 3, and that error will be caught by our error closure. Okay, so quickly let's run this code. Let's see what happens. Okay, beautiful. So you can see what's happening here, right? On data is called prints 1, 0, 1, 2 for us, And when it gets a tree, it throws an error, and that error is caught by our on error callback. And what does our on error callback do? It prints the error to the console and it prints the runtime type. So the runtime type is a string, and I threw a string here. So that's what's happening here. But you can see also that because it threw an error, the string didn't get to complete to 5. Remember, this is a for loop that goes from 0 to 5. Okay, so that's the essence of this this parameter, cancel on error. Okay, so if I were to pass an argument of false to this cancel on error in this listing call, it's going to handle this error gracefully and still continue to the next value. So let's see how that works in a minute. So cancel on error is false means it's not going to cancel when an error is true. So like I said, wow, that is an unexpected behavior. Guess we get to debug that later for the class, okay? But like I said, that namings are very, very intuitive. When you see the name of something, you already know what it does. Okay. So another way of Ngozi, you raised your hand. Guinea can raise
Yes,
hand too.
my network has been
Wait.
bad. I've not been hearing you, so that's why I've really been trying to get my feet back by watching the class again.
Okay, Ngozi, where did you lose me? Don't worry, this class will be uploaded on the YouTube. Where did you lose me, Ngozi?
Right from I don't know when you fixed all of this into the main function.
Okay, I'll do a quick recap
Okay,
of it now. So Ginika, please ask your question.
Okay, yes, thank you, please. The data, okay, data means print the results of the stream, right? That right? Like data is whatever is the result. Like you threw an exception I is equal to 3. That's the result. Is that what it means? Please, I'm using my future stuff to think about it. So I want to be sure.
Okay. So Ginika, you know what closures are, right?
Yes.
Okay. Closures are simply functions that capture the environment. You understand? So, and I explained for you to get the data emitted from a stream. From now, I'm going to be using the term emitted because what stream does is it emits data. For you to get the data emitted from a stream, you have to pass a closure function to it inside .listing method. Okay. Just this, when I write this code, streaming code to get messages, it's going to give me a stream, right? But the code inside the stream won't be run ever because that is smart enough to figure out that we have not actually listened to the stream. Maybe we don't need it yet. But when we call .listen, it tells that okay, we need data from this stream. Therefore, let's start running the code inside it. Okay, so moving on to the listing method, I opened up the documentation, the Hover documentation. So this is it. Ginika, can you see? Ginika, your hand is still up.
Yes.
You have
I
another
can.
question?
Yes. Like, okay, I'm trying to, I don't know whether I should read up on it or I should still ask.
Okay, just walk with me. Walk with me. Just follow me closely. Follow me closely, right?
Okay, let me just give it time.
Bring down your hand for now. Okay, so look at this listing method, right? You can see it takes in how many parameters? 4. Can you see 4?
Yes.
You can see 4. The first one is an on data. Okay. And what is the type of on data? Can you tell me?
It's an integer.
No, it's not an integer. Look closely.
Okay, it's a function.
Good. And what does the function take as parameter?
An integer.
Good. Okay. That means on data wants us to give it a function that takes an integer as parameter, right? And that is what we gave
Yes.
it here. So here, look at this. Can you see my highlighted code here, right?
Yes. Yes.
Okay, good. You can see that I've declared the closure that takes one parameter, and that parameter is an integer. Mind you, we can do this. Does this make sense now?
Yes. Yes, it does.
Okay, it takes one parameter, and that is what listen was asking us for, right? And what do we do with that one parameter? Can you tell me?
We printed it to the console.
Wonderful. We printed it to the console. Okay. So, but this can be anything you want to do. Maybe this stream gives you, like I mentioned before, maybe this stream gives you emits messages. Say you're building a chat application, kind of emits messages that are sent to you. This on data now will where you put your logic that maybe saves the message to a database, maybe or uploads it to the cloud or does any other thing you want it to do. Okay. That is on data. Okay. So what is the second parameter that it takes here? Can you see?
Yes, on error, a function on
Okay.
error.
Good. Why this exists is because we know that most times in programs, something can occur and something will go wrong and the whole program might crash. Okay. But we want to be able to handle error conditions. And look at this get messages code. We simulated an error condition. We said if I get to 3, throw an error. Okay, but this is a very, very primitive implementation. Maybe in your advanced implementation, you can have something that might go wrong and an error will just inevitably throw. Okay. So we give it an on error. And what that on error takes in the error object. Okay. And now what do we do with that error object? Can you see? Ginika?
Okay, we printed the type of the error.
Good. And we printed the error itself. Look at the first
Yes,
print
yes,
statement.
yes.
Okay. So do you understand now?
Okay, yes, but is it that the data cannot take another integer? What if it's a string that I'm listening for?
If it's a string, this string has to be of string type for you to listen for a string.
Okay, it
That
will be
means
changing. Okay, the
look
integer
at
that I
get
saw in that function, is it from this stream int?
yes, good. Look at the get
Okay,
messages. What type does it return? What type does it emit? Look at it closely. Tell me
an
what type does it
integer,
emit? Good. And
integer
because it
string.
emits an integer, when we want to listen to it, it's going to give us data of integers. That is why this data is of type integer. If you change this to a string, like it was before, this on data will take a parameter of string. Like that,
All
easy
right.
peasy.
Okay. Thank you so much. I
Okay.
understand now.
Okay, good. So this is stream.listen, right? This is how to use stream.listen, right? And I also I remember I said before that if you don't call listen, that won't know to start running your code or won't know to schedule your code on the event loop. Okay, you have to actually listen to it for it to start running. Okay, so this is what happens. But for someone, there's another use case. Okay, get the data from. Remember, I said you can. There's no other way. You have to listen to it, but I was wrong. Okay, there's another way you can get the data. Okay, this is a kind of a more primitive implementation, and this is what the listing uses under the hood, and that is an await for in loop. I don't know if anyone is familiar with for in loop, but this one now uses an await syntax. So we are going to have await for item. Most times this syntax is I forget them. So okay, wonderful. Okay, so this is another way of getting a value from a string. Okay. Remember we have this listen method, but we can also do this. Okay. And understand that for some people this may be much more friendlier because of you're only familiar with for loops and everything. So what this thing does is it treats this string. Remember you use you use for loops for iterables in that. Okay. But under the hood, a stream implements an iterable. Okay, that is why you can use a for loop. in it, and this awaits this thing is another syntax shoulder. But what this does is it waits asynchronously for each item that comes out from the stream, and it runs any code inside this block, these two curly braces. Okay, so what happens is I'm just gonna print item to show you what happens. Huh? Yeah, see, this will do the same thing that our listing method did. Okay, wonderful. So you can see it did the same thing that our listing method did, right? It just prints the items to the console 0, 1, 2 as they are emitted from the stream. So with this now, okay, you can wrap this await for block inside the try catch. Okay. And sort of catch an error. This is equivalent to having an error callback in your listing method. Okay. I want to print the error, and I want to print the runtime type of the error. Okay, so let's run this code to understand what it does. Okay, wonderful. So you can see what it does, right? When it gets to 3, it throws an interesting. Okay. Now this is a very common bug that I'm going to explain. This try catch block is supposed to wrap this whole stream. Okay. There's no bite on my parts right there. Sorry. Okay, but inside the await we print item. Okay. Let's inspect the behavior right now. Okay, wonderful. So you can see what happens here, right? We wrap the await for loop inside the try catch block, and what happens is that anytime if this stream throws an error or something happens or goes wrong, we are going to catch that error inside our catch block. Okay, and this is equivalent to the same thing. The thing we did is stream.list by passing on data and on error callbacks. Okay, so that is about streams. So a quick recap. Streams emit values asynchronously to you. Streams emit values. Thank God raised his hand. Sorry, I'm just seeing it now. Thank God, what was your question, please?
Yeah, so I was going to ask, can you scroll up a bit?
Yeah, this is up.
Okay. So we used the stream.listing method, right? And there was an option to whether to cancel on error or not. I heard you say you would get back to that. But my question is this: using the try catch method, is there a way to also implement that cancel on error? Did you get me?
Yes. Using the try, please come again. I didn't quite get.
You've shown us
Come
two
again, please.
ways to listen to the values from a stream.
Yeah.
Can you hear me?
Yes. Go ahead.
Can you hear me? All right. So you've shown
I can
us
hear you,
two
thank
ways
God.
to listen to the values from a stream. One is the stream.listing method, and the second one is the try catch that you've used. So with the stream.listing, we have an option to either cancel or continue on error, right? Now I'm asking, if I'm using the try catch method, is there a way I can also implement that?
No, I will explain that in a bit towards the ending of the class, okay? I will explain that part in a bit. That's a much more advanced implementation, but yes, it can be done. I'll explain how you can do that.
All
Okay.
right.
Thank God.
Yeah, I got you. Thank you.
All right, thank you very much. So so I've explained how you can create streams, create stream functions, okay? But the truth is when you be working or building applications, you are most likely not going to use this. You're most likely not going to be implementing stream functions like this with async stack because the use cases are not often. Okay, what you'll be encountering most times, or what you'll be using most times are stream controllers. Okay, stream controllers is just like a completer. Okay, it provides a way for somebody to kind of programmatically add values to the stream, to a stream. Okay, so what happens is when a stream, just think about this architecture, when a stream controller adds a value to a stream, okay, anybody that's listening to that stream is going to get that value. So a stream controller puts the value inside the stream and the value comes out at the other end of the stream. Okay, so that's what is basically a stream controller does. Okay, so I'm going to show us an example. I should have an example of that setup. Do I? Okay. Well, I will comment these examples and you can go through, but for now, let's use a live example to better understand what goes on. Okay. Okay. And Ngozi, please go ahead.
Okay, sir. Please, could you reiterate what you said about stream and stream controllers? Like when you were
About what?
comparing both of them. Please, could you just do a recap of what you said before you show the example?
Okay, I was saying most likely when you're working on applications or real world applications, you're most going to be using this type of syntax to create streams. Okay. You may find a use case where you need to do this, but most likely you'll not be using this. And what you'll be using instead is a stream controller. Okay. And the stream controller, what it does is it provides a way for you to add value to a stream programmatically. Okay. And I remember that I mentioned that a stream emits values. So when the controller adds the value to a stream, that stream is going to emit that value from, think of it as a pipe. You have one end, the right end and the left end. A stream controller puts a value in the right end from the left end. Okay, so this is the way to understand it. Because did you get that? Because did you get that?
Yes, sir. Even though my network was breaking in and out, but I
Where
get
did you
you.
lose me? Okay. Okay, thank you.
Mm.
So I'm going to show a live example of stream controller. So this is a live example of a stream controller. That is heavily an object-oriented programming language. So almost everything is an object. So this is how you define stream controllers. Okay. Yes, the object stream controller. Okay, and you have to give it the type that you want the stream to emit. So if I give the type of string, that means the stream is going to be, the associated stream is going to be a type of string, the generic type too. So that explains that. I think that's easy to understand. So now what you can do with this controller is you can see controller has a getter. And I wouldn't want to call it a member variable because most times that is getter as heavy. It has a getter called stream, right? And this stream is a type. of string like we've seen before. Explain what's going on here. So you can see that controller.string gives you a string. Okay, and this is the string that you'll be listening to. So what happens is that anytime you use this controller to add a value, that value is going to come out from this string. So let's use this previous example since it's the same name of the variable that we did. Okay. Yeah. I'm just gonna copy this. Put it. Okay, so what happens is anytime we use a controller, we call the method controller.add or controller.sync.add. That value is going to come out from the string. Okay, and because we print it here, we're going to see it in the console. So let's do a quick controller.add. For instance, let's do a for loop. We just want to add 5 values. Okay, each waiting an interval of 1 second. Okay, so now after 1 second, I'm going to call controller.add, and because the controller is defined as a type of string, I have to add only values of string type. So let's call this string value I. Okay, so when we run this code, I'm just gonna do what the previous one did. Okay, so you can see what it does, right? Controller dot add puts value in this string, and that value is emitted, and our listen closures catch it. Okay. Can also do this with controller dot sync dot add. It's still the same thing, but and just use controller dot add. That's less syntax sugar. Okay, just like having error conditions, you can also simulate an error condition with a controller by doing a controller dot add error. So here I'm throwing an error of type string. Okay, so when I run this code, simulate an error condition right there. So if I equal to 4, submit an error. But before that, let's just keep adding. Let's keep adding values till it gets to 4, just to show you how to submit an error condition. So when we run this code, this is the behavior, gets to string value 0, 1, 2, 3, and of course, when it gets to 4, it throws an error, controller error. And look at what our on error callback is doing. Remember, it prints the error and prints the runtime type. That's why you have controller error here, and you have string. String is the type of the error. Okay, so that's basically how a controller works. Yeah. And the beautiful thing about, although a much more advanced use cases, the beautiful thing about streams is that you can compose them. You can compose streams. Okay. Okay. For instance, say now stream. So we have these get messages. Okay. And when we want to funnel the data, to this string. Okay. that provides an easy way for us to do that. Okay, so how we can do that is by doing the controller dot add stream. Of course, you have to call this outside the for loop, because controller the hash stream. Okay, and the stream we give it is get messages. So when we run this code now, what's going to happen is the stream is going to emit values of stream value 0, 1, 2, 3 up to 5. And when it is done, okay, it's now going to emit values from this particular stream itself. So let's see how that works in a minute. Sorry. Okay, you can see it's running. Okay, wonderful. So you can see after doing that, it kind of gets the value from the other stream and start emitting it to you. So this just shows you a fraction of the power of controller.add stream and controllers, what they can do. Okay, and they are a much more advanced use case where you might need to do these things, okay? And that provides you these functionalities. So that's about stream controllers. Ginika, you raised your hand. Okay, what's your question?
Yeah, so you're trying to say that you can add a stream to a stream, right?
Beautiful. You understand it.
Okay, the second thing is
think of it. Think
okay,
of it.
go ahead.
Think of it as funneling data. Say you have like a funnel, but you want to connect it to another funnel.
Okay.
So the importance of this now is, imagine we have other streams. Imagine we have other stream functions. They do different things. We get them from different places, right? But we don't want to be calling. You don't want to call listen on each of those streams. We just want to funnel them through one output, and that is this particular one. We can accumulate all of them into this one controller.stream. For instance, let's say, let me just show you an example. So this one is get messages 1, get messages 2, all right? So you can see we have 3 stream functions, right? For us to get the values from these stream functions, we have to listen to all of them individually, okay? But maybe we don't want to do that. We just want to access them from one central point. So what I'll do is, I'll do a controller dot add string get messages 1 controller dot add string get messages 2. So you can see these 3 independent streams now. All the data will be funneled through this one controller stream. Does that make sense? Do you understand me, Ginika?
Yes, I
Okay,
get
good.
you. Yes.
And they all come out the central point where you listen to them. Okay, so this just shows you a fraction of the power of stream controllers, and also the other things you can do with them. Okay, so moving forward,
Okay, I wanted
we're
to
almost done
ask.
with. Go ahead.
I wanted to ask another one. Please, can you scroll up again? Please go down a little.
Go ahead.
From the beginning of the main function. And the console is covering the main function. Okay, yes, here. So the line 35, final string. Is there a need to still call the type on that variable stream? Like, what's it doing? Since we are like, is it compulsory to, can't we just declare it final stream?
No, to answer your question, it's not compulsory. Just like you every other object, that's how the system called type inference. Basically, it infers a type of a variable from the right-hand side. Okay, so we can remove this thing. I will just show you this example to show you that the stream has to be of type of the parameter you passed to the stream controller when you created it. Okay, if we do this, the IDE was going to scream at us, as you can see. because you are saying you want a stream controller that emits values of integers, but we are assigning it to stream of string. It has to match.
Okay.
Okay.
Okay. But is
Okay,
it
so
compulsory to really
that's that.
declare?
So we can. It's not actually compulsory. See, you can see everything is good now. Everywhere is
All
good.
right.
The
All right.
IDE is
Thank
not
you,
screaming at
please.
us. Okay,
Okay,
and
thank you, please.
in addition to, yes, in addition to, it's not necessary to assign it to a variable. You can call controller.listing directly. Okay, it just depends. Can you see this? This works too.
Yeah, okay,
Okay.
please. Yeah, thank you so much.
Okay. Ngozi, ask your question.
Yeah, I was going to ask whether the stream you used to declare, that's before you deleted the line 35. Can you put it back on? Just so this this stream name you gave it here, and then this controller the stream was kind of confusing me. So if we were to change one name, which of them would we change? Because we have stream here, stream here.
Good. Sorry, I don't understand your question. Which name do you want to change?
Is it that we can use any name here when declaring this
Of course.
final stream? That's what I'm saying. If we were to change the name, which one do we change? Can we use any name here? Okay.
You can change to, you know how you can name your variables anything. This is basically a variable. See the same thing. Stream of integers.
Okay.
Names are not
Okay.
really the important thing.
Okay.
Okay, so that's that. So I forgot to mention one more thing. Well, I left it intentionally. I wanted to mention it at the end of the stream discussion. Streams are built such a way that they can only listen to them once. Okay, so if I do this now, this doesn't work. I can't listen to this string twice. So if I run this code, it should throw us an error. So let's run it. Okay, wonderful. So you can see the error in my terminal. It says, and this is a common error that you might run into if you're not really familiar with streams. Listening to it twice. They can only be listened to in one place. Okay, so, and this is a challenge for most people because most times you might want to listen to the stream in multiple places in your application code. Okay, but you cannot do this. You cannot do this. Okay, so, well, of course, as there's any limitation, there's always a solution to the problem. The solution is that there are two types of streams. There's a normal stream, and there's a broadcast stream. So let me repeat again. There's a normal stream, which I've explained here, and there's a broadcast stream. Okay. So their implementations, you don't necessarily have any, they're not different. They all implement the same interfaces. Okay, but their implementation, their concrete implementations have different, are nuanced differently. Okay, so you can only listen to a stream twice if the stream is a broadcast stream. Okay, let me repeat that. You can only listen to a stream twice if the stream is a broadcast stream. So how do you make a stream broadcast? You can either do this if it's a stream controller you are using. So if it's a stream controller you are using, you have to declare the stream controller as a broadcast. But if it's a normal stream that you are using, you have to, first of all, get the stream, then call a method dot as broadcast on it. For instance, before I move over to the stream controller example, we have this, let me rename this thing to stream. I really don't like long names. Okay, name this into stream. Okay, so let's call this So if I want to listen to the stream first, what I do, I have to convert to a broadcast stream. Keyword being convert as broadcast stream. So you can see that I've called as broadcast stream on this object stream, and I'm assigning it to stream. So if we do this, so let's annotate these things a bit so you can understand where each value is printed from. From listener 1. Let's call this from listener 2. Okay, wonderful. So when we run this code, it's not gonna throw us on. Oops. That is an unexpected behavior. I forget the syntax sometimes. Okay, so this is what it should be. You're supposed to call it before you create it. This is a let's look at it. Okay, this is a named constructor. You know, that has the concept of named constructors, right? So instead of this, right, this is what we do. This is how to create a broadcast stream controller. So with this, we should be able to listen to this stream twice. Okay. Let's run this example again. Yes,
Hello,
there's
sir.
something wrong somewhere, and because of time, we don't have time to actually debug to find out where the error is coming from. But
Hello,
to
sir.
understand the concept, okay, there are
Your
two
screen
types
is
of
not
streams.
moving.
There are broadcast streams and there are streams. Okay, the broadcast streams enable you to listen to it more than once, but streams can only listen to it once. So to explain my point, right, you can see before when we did this without making this a broadcast stream, when we did this without making
Hello,
this a
Mr.
broadcast,
Collins.
sorry.
Your screen is not moving. Oh. It's stuck.
Ginika,
Can you hear me, sir?
yes.
Your screen is stuck. I don't know. Is it that you're not moving it or it's just
Is
there?
anyone else having the same issue? Is my screen moving?
It's the same thing, yes,
Yes,
our screen is not
the
moving.
screen is not moving.
Okay, sorry about that, guys. I just came back. My network was a bit challenging. So Please confirm you can see my screen.
Yes, sir, we can.
Okay, wonderful. So I was explaining broadcast stream, and it seems we have something going wrong somewhere. Okay, and that can be an assignment for you to find out. I will upload this code, of course, to find out if something is going wrong. Okay, so the difference between broadcast stream is with the broadcast stream, you can listen to it more than twice. Okay, so you can have this multiple control.stream.listen called different places in your code base. Okay, so but if this is not a broadcast stream, you can see though it is not going to emit a value, which we are going to fix in our next class. Okay, you can see that it doesn't throw an exception. But if this was just a normal string, if we try to do this, it's going to throw an exception or an error, whatever you call it. So you can see it throws an error because you try to do this, right? Okay. So, and that's for streams and stream controllers. Okay. Oh, okay. So the reason why this string didn't give us any value was because we didn't add any value to it. I was wondering why we didn't catch that. Okay. So let's add some values to it. Okay. And let's see how it works. Remember, I told you that you must add the value for it to come out. So let's call stream value I plus 1. So when we do this now, and we're using a broadcast stream. Thank you very much. When we run this code now, it should behave as expected. Okay, wonderful. Okay, so let's inspect the output of this program. You can see from listener 1 is called, and from listener 2 is called. You can see from listener 2 here it's called. From listener 1 is called. That means we're able to listen to this stream from multiple places in our code base. Okay, and that's and as opposed to doing it on a normal stream. So if we did this like you've seen before, exception. So that's that. And that brings us to the end of advanced asynchronous concepts. So if you have any questions regarding this, please call my attention to it before we move over to abstraction and encapsulation, OOP concepts, because that's what we are supposed to deal with this week. So if you have any question, please let me know.
Mr. Collins.
Yes, you can just call me Collins, please.
Okay, please.
Go ahead with your
My
question.
issue is not a question of the code, is the terminal, because I self-learned. So this whole command of terminal, I'm not really good at it. So after pulling the code from the repository, I didn't know how to run it. Even when I checked online, they were like, navigate the document, navigate the file path to the part where the code, God, I didn't even understand what they were saying. So I don't know if you can, I don't know how do you make your, like I observed that you are on the file type in the terminal. How do I do that? Because I don't know how to run
Okay.
the code.
To run your code, you have to invoke the dat virtual machine, the dat interpreter. Okay, and how you do that is open up your terminal. And of course, to invoke a dat code, it has to have a main function. Okay, is your main function. So let's inspect. Look at this left panel, for instance. This is a Flutter project, but I'm not running that code inside it. Okay, my files are located inside lib folder. Okay, and each of these files have a main function. That's why I'm able to run it. So I'm on a Linux. I'm on a Linux Ubuntu machine. Okay, so you have to cd inside this folder where your executable file is located. So to print my current folder, this is what it does. So this is my current folder. Can you see my screen? Because my terminal.
Yes, I can.
You can see the path. I'm at home/collins/document/project/flutter course. Okay, but my this file, the name of this file is streams and stream controllers, right? It's located inside flutter course/lib. So I have to navigate inside that folder. And how do I do that? In my terminal, I do a cd. Cd means change directory. And because
Okay.
lib is a child directory inside Flutter course, I can just do this. So you can see when I do pwd means print working directory. And mind you, if you're on a Windows system, the commands might be slightly different, but they do the same thing. So if I do pwd, you can see it prints that I'm in home/collins/document/project/flutter course/lib. So when I'm inside here now, I can run any file with that command. To invoke that VM or interpreter, you just have to write that, then give it the name of the file you want to run. Streams and stream controllers. Okay, the name is quite long, so I don't want to have to type it out myself. So I just print list means list all the files in your directory. I just copy the name of the file. To do that, give it the name of the file. Can you see my terminal? Because
Yes, I can see your terminal. Okay.
wonderful. So when I do this, it's just
You're
gonna
calling
find
my name. I'm not the
a
one
file
you're
because it's already.
talking to. You are calling Ngozi Ngozi. I'm not the one.
Okay, sorry about that. Okay, so when I do this, it's gonna find my file and run the code. You can see it runs the code, right? So this is how to do that.
Okay. All
Okay.
right.
So
Thank you so
Ngozi, you
much.
raised your hand. Sorry, because I was seeing your hand raised. That's why I was calling you. Ngozi, what was the question?
Okay, so when you said, do we have any further question before we move to object-oriented programming? I just wanted to say that I do not have any question, but for me, going back is like very crucial. Like looking at these codes all over again from the beginning to understand it, and then possible questions might now surface. But for now, I think I'm good.
All right, that's fine. That's fine. Of course, I'll open this code. It's the module material. Our module materials, our classes are practical classes. So our module material is going to mostly be code repository. So you can go through it, and do not hesitate to reach out with your questions on the group. I know
Please,
even
sir,
though we don't have classes in
have you added this? Have you added this
added
to
what?
the repository? Like this new code, have you pushed
I
them?
will. When I do, and I'll let you know. Okay,
All
I
right.
will.
All
Like
right,
I
sir.
said
Thank you, sir.
previously, yes. Okay. So, well, let me please your question.
Hi, good afternoon.
Yeah. Good evening.
Good evening. So I want to ask, you mentioned earlier that the stream use case is not often used. So I want to ask, like the whole concept of asynchronous system, what's like a real life use case so that we can like have that in mind as we learn forward.
Okay. We're going to be encountering a lot of use cases. Okay. Remember I said in the course of this learning, you're going to build an application called Certify. Okay. And when we start building that, basically you will build the application. Okay. You see the use cases for these things. But just to answer your question briefly, right? Streams emit values asynchronously. Streams emit a sequence of values asynchronously. Futures emit just one value. Okay, so that's the important difference between a stream and a future. But both of them are very, very important key entities in asynchronous programming. That keyword being asynchronous. Synchronous means it doesn't block any other thing from running. And asynchronous is very, very important when building applications because it is not just your code. that is being run when an application is running. It is not just your code. I know you might think that it's just our code that is running when you're running an application, but no. If the application, to be precise, it is not just your code. There's background code that is running and updating the frames that is being displayed on your phone. Okay, Flutter has the essence of Flutter has a runtime system and its own code that does this in the background. So if you use synchronous methods, they might block what Flutter is supposed to do, and you notice hanging on the application. That is why asynchronous methods are very important. If you do things synchronously, it will cause jank. Jank means frames skipping. Okay, so Flutter has to redraw each frame, most times 60 FPS, 60 frames per second. So if you do anything that's going to block it, it's going to cause jank in your application. That is why these asynchronous concepts are really, really important when building applications, UI applications to be precise. Okay, so, and of course, we're going to see use cases for this thing. So I hope that answers your question, Olamide.
Yes. Thank you very much.
Yeah, okay. So the last thing we have for today, this is to be very brief one, and I'm sure we are familiar with OOP, but this is what you'll be seeing a lot. Okay. Abstraction and encapsulation. I already prepared some examples for us. So let me just move over to the file. Okay, so this is the file for abstraction and encapsulation. Okay. Most of the times in software, especially when you're building end user applications, you don't care much about abstraction. You just want to write code that runs. You just script it. But you forget that architecting the code is a very, very important step. Because if you don't architect your code or plan it from the beginning, when you come back 6 months or when you want to maintain that code, it will become very, 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 very overwhelming for you, because most times you might not remember where things are. Or even if you remember where things are, if you change something here, it will break something there. Your system is tightly coupled. You can't even do anything without changing something there. For it to implement one feature, you have to rewrite a very huge part of the code base. Okay, so this is the importance of concepts like abstraction and encapsulation. Abstraction, to be precise, right? So what abstraction does is it's kind of it specifies the contract of your application. It specifies it lays out the behavior, how certain things will behave and how certain things will communicate. Understand? But it doesn't specify the details of how it does what it does. Okay, it just shows you this is what this thing does. Think of it as like a blueprint. Okay, as a blueprint of a house. As an architect, you can draw blueprints of a house. Okay, so the blueprint shows you this is how the house will be, this is where things will be, this is where it will be. But they don't show you the house is not actually built, right? So that's the concept of abstraction in a nutshell. Okay, so to explain the concept in code, abstractions are usually built with abstract classes. Okay, an abstract class is a class that declares an interface or an abstract keyword in that. If for someone coming from Java, Java has the keyword interfaces too, so you might be familiar with that. Okay, so an abstract class kind of declares the methods it has without actually writing, without actually having the code of how it does what it does. Okay, so this shouldn't be here, although it can be here, but it shouldn't be here for examples. Okay, so can see we declared an abstract class vehicle. What this thing means is, just work with me with this example, right? Sometimes this concept can be hard to wrap your head around. We declare an abstract class vehicle, and we declare what a vehicle can do. Okay, so we are saying a vehicle, you can start the engine, you can stop the engine, and you can drive. Okay. Okay, but of course, a vehicle can be anything. A vehicle can be a car, a vehicle can be a trailer, a lorry, and everything. And each of these vehicles can have different modes of driving. or different protocols for stopping the engine. For some vehicles, if you want to stop the engine, you just turn the key anti-clockwise. For some, you have to, do some other rituals or ceremonies to stop the vehicle. Okay. So, but the important thing is that they are all vehicles and they have a common interface. The interface is that you can start engine, stop engine, and drive. This is your abstract class. Okay. When you have the abstract class out of the way, you now have to think about the concrete implementations of these abstractions. You now have to think about, okay. So when you now think about the concrete implementation, you now be like, okay, yes, a car is a concrete implementation I want to have, or maybe you want to have a trailer or something else, right? That concrete implementation is where you now define the logic for that behavior. Okay, so you can see, look at this example, for instance. Okay, this car example, you can see the code is much longer than the first one, because this is where the implementation details are outlined. So you can see a car declares how it starts its own engine. Okay. So and of course you have to extend the abstract class. Sometimes you can use an implement keyword. Is different. Sorry, give me a minute there. An implement and extend keywords are different. Implement means you want to override everything from scratch. And extend means this abstract class may have some default concrete implementation that you want to reuse inside this child class. Okay. So for implements means we want to implement everything from scratch. Just to show you how that works, right? Assuming we have let's just call this base concrete implementation, right? Okay. So you can see, because I use the implement keyword, even though these things have method bodies, right? The IDE still screams at me, telling me that I need to implement it because I use the implement keyword. But if I replace this with an extends keyword, okay, extends keyword, you can see the IDE stops screaming at me. And why is that? It's because I'm only extending, not implementing. Mind you, with the extends keyword, I can also provide my own implementations for vehicle. Okay. I can also provide my own board. It kind of gives me batteries to start with. Okay. And these are very, very different use cases. Okay. So this is for abstraction. You abstract away the interface of what your system looks like from the implementation details. Okay. So a real life application example of this would be when you're trying to decouple your applications, right? Most time in application you have things like services, repositories, and controllers, especially when you're using the Get state management system, which we'll be using in this course. You have your controllers, you have your repositories, and you have your services. Okay. So a repository represents data source. Okay. Your data could come from cloud, it could come from your device, it could come from a database stored from somewhere. So a repository kind of abstracts that. Okay. So to show you an example, quick example. So imagine we are building an application and we want to implement an abstract repository. We can do this abstract interface class repository, and we declare what our repository want our repository to do. Let's say we have a data model called certificate, for instance, certificates. Okay. Remember, I said a repository represents a data source where data comes from. So maybe you want a method that says that gives us a list of certificate. So what we name it get certificate. Okay. Okay. We want one that saves the certificate. Okay. We will call it save certificate. Now notice what's happening here. Okay. I've declared the contract of this repository. I'm saying a repository has two methods called get certificate and save certificate, right? But I'm not actually defining the logic that happens. Okay. So remember I said the data could come from the cloud, it will come from the device, it go from a backend or a database. Your data source can come from anywhere, honestly. Understand? So we don't want to hard code all those things. So you can provide different implementations for different sources the data will come from. And how do you do that? You do for instance, I want to do a cloud repository. I want to implement a cloud repository. So, of course, you do the implements keyword. Of course, ID screams that you have to implement it. So what happens now is that this cloud repository is where I put the logic that gets those certificates from the cloud. Okay. Okay. So I can put the logic. Maybe you don't have any logic that does that for now, but this is where you can do that. And of course, you must return certificates. So this is what happens. And you can maybe you want to save the certificate to cloud. This is where you put the logic for doing that. Now, the importance of this is that the rest of your application code does not see this cloud repository. Okay, what they will see is this repository interface that you declared here. This is what you export. Okay, you don't export this one. This one is implementation details, is internal. Okay, this is what you export. Rather, how applications get hold of this is through dependency injection. Okay, you will inject this complete implementation through dependency injection. But other parts of the application, I know this concept may be sounding abstract for now, but we are going to see, you're going to get hands-on how using them when we are building our certified application. Okay, so you inject this complete implementation with dependency injection. Okay, but the rest of the application will only see this. For instance, you could do something like this. For instance, if you come in your function, in your main function, okay, and you do a find now repository. I just call this repo. Okay. So I'm only creating a variable or repository. I'm not doing this because why is that? Because okay, I think I am commented that for a second. Okay. Let me comment that. I'm not doing this cloud repository because cloud repository is a concrete implementation. I don't need the concrete implementation. I just need the contract. Okay. So now, assuming there is a function that injects a cloud repository, let's name that function repository. I just call it inject cloud repo. So what this is gonna do is it's just gonna provide me with the concrete implementation, right? So now what I do is instead of calling this constructor directly, I just get it from somewhere. Of course, with get there are more advanced dependency injection systems. Okay. So now what I do is I call the methods through the contract. Okay. Get certificate repo dot save certificate. Okay. Okay. Now you can see that the type of repository is repository. A repository is an abstraction. Okay. And the dependency injection system gives me the complete foundation. okay? But we're using a very, very simplified use case here. Okay, so this is just a fraction of what you could do with abstractions, right? So with this now, what happens is that you can have another implementation of a repository. You can have, let's say, local storage repository, and of course, it has to implement repository. Okay, you provide concrete implementations. Now, this cloud one gets a certificate from the cloud. This one saves the cloud. Now, local storage repository, what it does is it gets it from your local storage, from your device. Maybe it is saved in your device as a file. This is the one that will get it. Okay. And this save one will save it to your device too. Okay. So you can also inject the concrete implementation through an injection function. Okay. Okay. Repository. Let's call this one inject local repo. You can see instead of returning a cloud repository, I'm returning a local storage repository. You can see now in this main function where I'm using both. If I want the cloud, I just inject the cloud. Okay. If I want the local, I just inject the local. It doesn't really matter. It doesn't really matter. Okay, the interface stays the same. I can get certificates and I can save certificates. So this just shows you what you can do with abstraction. It abstracts away the detail from the actual implementation. Now, what this thing means is that, okay, the implication of this is that if you want to change something for local storage repository, okay, you don't have to also go and change it for cloud repository. Let's say there are parts of your application that are using the cloud repository to save certificates in the cloud, and maybe there's a bug in your local storage repository. You don't need to touch cloud if cloud is okay, because your applications, other code is only seeing repository here. They're not seeing the concrete implementations. You just have to go into your local storage repository and fine-tune the logic or fix the bug inside there. Okay, so this is important to abstraction. Therefore, maintaining your code base will be much easier. Okay, so encapsulation is not so different from abstraction. There's some encapsulation in this example. Okay, so back to this very cool example that I already had prepared. Encapsulation basically means storing values, keeping values hidden. Okay, keeping values hidden. And how do you do that? In Dart, you do that by prefixing your stuff, your variable with an underscore. Okay, some languages have the keyword private, public, etc. In Java, it is called private. I think in C++, it's called private too. Yes, C++ private. The TypeScript has their own, each language has their own. Python. In Python too, just like that, you have to prefix an underscore. Okay. So what this thing means is that this count variable cannot be accessed. Okay. This count variable cannot be accessed outside the implementation. Okay. Any code outside this beginning brace to this end brace here will not access count. They're basically making it hidden. Okay. Mind you, this count can stand for a lot of things. Maybe it can stand for the number of times you try to start the car or do something. It basically hide the value because other parts of the application do not need to know about it. So that's what encapsulation is all about. And I think that brings us to the end of today's class. So if you have any question about abstraction and encapsulation, please feel free to ask now. Okay, because please go ahead with your question.
Okay, so I tried to follow you as you were going, but I got so lost. I don't even understand. In fact, I've been lost from the beginning, just that I didn't want to interrupt as you were moving. The abstraction, both the abstraction and the encapsulation. So
Okay.
I guess I'm just going to go back and look at this again. Because I don't understand at all. I understood when you started in the beginning, but as you went on, I got lost.
Let me just do a quick recap, okay, of it. Basically, the importance of abstraction is it provides a way for us to specify, for us to say what each part of our code does, what our code does, without providing details of how it does it, without providing the actual logic. Okay. And the reason that is important is it helps us decouple applications, and we can have different implementations of the same thing. Okay. I gave an example of a repository, and I said a repository represents, for our use case now, a repository represents data source, where data comes from. Okay. And you know that in applications, data can come from your backend, data can come from a cloud or cloud service, data can come from even the device, the device, the user's device. Maybe it's a saved file or some saved information I want to access. So a repository kind of abstracts that. It says, okay, this is where data can come from, but it doesn't say how the data comes. Okay, so I gave an example with this first abstract method. Mind you, these are called abstract methods. Methods without concrete implementation are called abstract methods. And only abstract classes can have abstract method. So if you try to do this, if you remove the keyword abstract interface and try to do this, you see the IDE will scream at us, because let's see what it says. Say, okay, get certificates must have a method body because repository isn't abstract. Okay, so let's add that back, right? So we specify that a repository, for our use case, a repository should be able to give us a list of certificates, and a repository should be able to save certificates for us. Okay, but we can decide to save a certificate in our backend if we have one. We can decide to save a certificate in the cloud if you're using a cloud service, maybe Firebase storage or Amazon S3 buckets or any of those cloud services. Okay, you can decide to save it there, or we can decide to save it in the user's phone, the user's device, the user's file system. Okay, so the repository does not tell us how to save it in each of those things. It just tells us what needs to be done. Okay, because are you following me?
Yes, I am. I'm following.
Okay, so your repository just tells us what needs to be done. So when we now want to save it in the cloud, okay, we have to provide a cloud implementation of this repository, and that is what I did here. Can you see this code I just uncommented right now?
Yes.
Forgive this primitive example, we're not actually sending anything to the cloud now, but I'm just using it for demonstration purposes. Okay, you provide, I can just say saved certificate kits to cloud. Okay, now these are the concrete implementations of repository for the cloud, keyword being for the cloud.
Yeah.
Now I want to provide a way for users to save it in their local device instead of in the cloud, so that maybe they can be accessed without internet connection. Okay, therefore I provide a local storage implementation. So can you see this code I just uncommented right now?
Oh, yes. Local storage. Yes. Repository.
Okay, very, very important. So sorry, let me just comment this cloud one. Okay, so let's just see, this one just prints saved certificate to user's device. Okay. And once again, please forgive this naive implementation. We are not actually saving anything to any device for now. We need just to demonstrate what it does. Okay. So in us, we have a local storage implementation and a cloud implementation. Now, other parts of the importance of abstraction is that other parts of your application will not see cloud repository or local storage repository. Okay, what they only see is the contract. Are you following me, Ngozi?
You said contract or what? Did you say contract?
The contract is the interface. The interface is the abstract class. Look at this contract.
Okay.
Can you see what I'm highlighting here?
Yes.
Okay. Other parts of the application that need a repository, they don't care about whether it's cloud or local storage. They just want a repository to save something. Other parts of the application. For instance, look at this main function. Okay. Let's use this main function as an example. Okay. So in the main function, look at this main function, for instance, we want to use a repository. Okay. Can you see this main function?
Yes, I can.
Because
Yes.
okay, you can see that each type is set as repository. Okay. And repository is an abstraction. Can you see this? It's an abstraction. It also have many complete implementations.
Yes. Yes.
Okay, wonderful. So I want to save get certificate, right? So now the question is, the rest of the application, what they get to see is the abstraction. They don't see the concrete implementation. So then how do you now get the code to work? It is through something called dependency injection. You inject the dependency. Okay. In this injection function. Here we have a function that injects a cloud repository as a repository. And we have one that injects a local repo as repo. Can you see it? So if I
Yeah,
run
is it
this
the
code now,
inject cloud repo and inject the other one, local?
okay, so
Yeah.
okay, wonderful. So the main function doesn't really care whether it's local or cloud. So but what the dependency injection function does is it gives us a concrete implementation. So when I run this code, let me quickly run this code. So you see what it does. Oh, sorry, that's that command. Okay. Okay, wonderful. You can see here we injected the local storage implementation here. We are trying to save a certificate. That's why it printed save certificate to user's device. Okay. If we inject a cloud repo, okay, the implementation is going to change. Okay, it's gonna say saved certificate to cloud. Can you see what's going on? Can you see what's going on?
Yes, I can see. It's good.
Okay. The key thing to note here is that the main function really doesn't care what the concrete implementation is. It just says, I want a repository. Give me a repository. Can you see what I'm highlighting right here?
Yes.
Okay, it just says, I want a repository. Give me a repository. So, and this is what it does. Okay,
So what's
I
the
know
like
this
what I understand what you're saying, you've been saying since you started to explain. So now how do I use this practically? I'm sorry, I may not have gotten it at
Okay,
first when you explained, but now that I understand better, how do I actually use this thing now that I'm understanding?
how to use it is you use abstractions, like I said, to decouple applications. Okay, without abstractions, okay, okay, when you write code, if you want to change one thing, it's most likely going to break something else.
Okay.
these things are best demonstrated with an actual example. Don't worry, when we start building our application, you'll see better use cases for this, right? So without abstractions, it will be hard to maintain your code. If you come back, let's say 6 months later to maybe implement a new feature or something, you may forget where things are. If you don't forget where things are, you may be very, very, very skeptical of implementing something because you are scared that if you just add this thing now, maybe every other code that uses that code might break or change, or your IDE will scream at you. But if you define clear interfaces of what your code does, and each part of the code communicates through those interfaces, you don't have to worry about whether something will break. You can implement new things with gracefully. Rather, let me use that term, gracefully. So that's the importance of abstractions, and we'll be seeing those use cases in the future when we start doing our application. Okay. So this is already 6:58. Wow, this has been a very, very long class. Thank you all for joining. I hope there's no other question.
Sir, please, I want to
Okay.
ask the video, when will
Yes.
it be, that the video for the class, this class and the last one, when will it be uploaded?
It should be out this night. Okay, the program manager will work on it and provide it to you guys. I will let you know when the video is up.
Okay, sir.
So
Thank you, sir, for that one.
Yes,
all right,
Thank
thank you very much for joining.
Hey. Okay, will we repeat this thing in the next class, or this is the end for abstraction?
No, we will not repeat this topic in the next class. We will only be building on top of the concept we've already learned. Okay, but the way I explain it now, I will not be doing that in the next class. Unless you have a question, I need to take us back.
Because it's almost the end of the class, but I just wanted to know that this abstraction, is it for methods that is it a middleman between our data class, like where we fetch APIs from, and then I don't know if
Thank you very much, Kinika. That is a use case of it. That is a use case of it. It can be like a middleman, something that kind of specifies the contract. How do these different parts communicate? You can use abstractions there, okay? And then there are other use cases too. Okay, so you can come up with your own depending on what you do. Okay, so
okay, so
that's that.
I also want to understand, because you did cloud repository and you did local storage. So is it
Okay.
also like functions that we are going to be reusing all the time that we can put there, that
Yes,
communicates
it
between
also
our data
serves
class and data class?
abstraction also serves for reusability. Okay. Abstraction also serves for reusability. There are many, many, many use cases. Okay. They're very, very smart people that came up with this idea. They know why they came up with it, and it is very, very useful. Basically, I dare say you can't build scalable systems that you can scale whenever you want to without abstractions, because the context is just so large. Okay, you just need to abstract a lot of things for you to know, for you to have that scalability. Let me just use that word, scalability. Don't worry, guys. Don't worry. You'll be getting hands-on practice on this when we start building our application. Okay, so just be gathering the knowledge for now. Thank you very much. I think this is 7 o'clock, 7:01 actually. All right. Thank you for joining. See you in our next class.
Bye.
Thank you very much, sir.